You got a pretty good idea what chemistry is, right? It's atoms and molecules doing stuff and making cars and food and life and everything. And of course, it's the study of those things. But how did we get here? There's certainly no everyday evidence for much of what we have discovered through the science of chemistry. Discoveries that were not derived or made up, but just laws of the universe that exist simply because the universe is the way the universe is. So in today's episode of Crash Course Chemistry, we're going to be taking a bit of a historical perspective on the creation of the science of chemistry. A science that didn't really even exist until a super smart, super wealthy French guy put the puzzle pieces together into a coherent theory for quite literally how everything works. And if you've ever found yourself sitting at your desk reading the same line in your chemistry book the 22nd time, and you think to yourself, "Gah, the guy who invented chemistry should be put to death," well, you should feel bad, because he was. Antoine Lavoisier was pretty fantastic. He was a geologist, a botanist, a biologist, and a physicist. He helped define the metric system, created an international language of chemistry, named hydrogen and oxygen, predicted the existence of silicon, outlined what elements were, figured out how animals extracted energy from food, determined that an element could take different forms upon discovering that both ash and diamond contained pure carbon, published the very first chemistry textbook ever, and there's a reason why the law of conservation of mass used to be called Lavoisier's law. Born into a wealthy family, Lavoisier inherited a massive amount of money when his mom died when he was 5 years old, and though he did get licensed to practice law as his father expected him to follow in his lawyerly footsteps, young Antoine chose science instead. When the opportunity arose to marry a wealthy girl whose father's massive income came from collecting taxes for the French government, he did it, even though she was 13? A questionable decision, though not uncommon at the time. It turned out that the family connections would be his undoing, though, not the age of the bride at her marriage. Marie-Anne, as she grew older, would become a colleague as well as a wife, assisting Antoine in his experiments and his analysis of the work of others. Indeed, it was Marie-Anne who translated Essay on Phlogiston for Antoine, which he ripped to pieces, changing everything forever. Until Antoine Lavoisier started inspecting everybody's work, the prevailing theory of chemical change was that some substances contained an elusive element called phlogiston. By burning these phlogiston-containing elements, they would lose their phlogiston and become new things. Lavoisier took those theories and their research, combined it with research being done elsewhere, and added in his own genius experiments, and then tore the chemical world to pieces with a little thing called combustion. He determined that hydrogen wasn't inflammable air, it was an element. Indeed, he named it hydrogen because it was generated from water, or hydrogenated. And he determined that oxygen was a vital ingredient for combustion, and also what would later be known as oxidation, something that we'll discuss quite a lot in this course. By hooking people up to his bizarre contraptions, he determined that burning wood consumed the same amount of oxygen, and produced the same amount of carbon dioxide as people consuming food and breathing, thus determining that people, and all animals, are powered by some form of internal combustion. Now, experimenters of the day, I hesitate to call them chemists, notice that when you burn something, its mass decreased. Like, here's a fuse, and I put it on a scale, and I burn it, and its mass decreases. But Lavoisier determined that if all the particles and gas are collected, like if I burn the fuse inside a closed bottle, the mass stays the same. Stuff remained stuff. You can't lose any. You couldn't make more. This realization, though it seems obvious to us now, and its acceptance by the general scientific community, as far as I'm concerned, was the precise moment at which alchemy ended and chemistry began. Lavoisier's chief contributions and ultimately his discovery of the law of conservation of mass relied on careful measurement and careful thinking, and as you'll see, both of those things are key to success in chemistry to this day. Lavoisier the man was a bit of a dichotomy, having worked as a tax collector and helping to create a literal wall around Paris to assist in the collection of taxes, but also a supporter of the French Revolution as it began. But the enemies he had made with his wall, and by denying certain powerful politicians entry into the French Academy of Sciences, eventually caught up with him as the revolution's lunacy increased. He was beheaded on May 8th, 17